Okay, so before you're watching this, you should have gone through the narrated PowerPoints already and seen that one of the things we often do in working with this type of data is build what's called a scattergram, or sometimes called a scatter plot graph. It's a little bit like the frequency distribution graphs that we did all the way back in chapter 2, a little bit. And as you've seen in those, that's often considered sort of prep work to doing one of these. In a classroom sense, you only have to graph, you only have to make a scattergram if you're told to in the question. But it gives us a head start on what to expect from our mathematical analysis. Should we be expecting a number close to 0 or a number very far from 0, a low value, a high value, all that kind of stuff. It can also, as I've talked about in the PowerPoints, can also tell you which math to do. The math that we're specifically doing is called a Pearson R. So we started with Z tests in chapter 8, and we had 3 chapters of T tests, 2 chapters of F tests, and what we're doing now is an R test, a lowercase r. R is in relationship. There are many different ways of computing what we call coefficient correlations, of computing these coefficient values. There's lots of different ones depending on what type of data you're working with. We'll see that later in the chapter. But the only one we're going to learn how to do, and quite frankly, they're all pretty similar, they're all basically versions of the Pearson, is this specific test. So it's still a hypothesis test. We're still asking, are things, is there a pattern or is there not a pattern? We're not asking if things are different or if they've changed. We're simply asking, is there a pattern or is there not a pattern? And the other thing that comes back, before we get into this list, the other thing that comes back to us in this chapter for better and worse is one-tailed tests and two-tailed tests, because we're back to having positive values and negative values. So we need to know, are we looking to the right or the left or both? So as our normal pattern would be, we're starting with the two-tails version. So before we get into the specifics of what that looks like in our regular 4 steps, we're going to continue our recent tradition of having a preparation stage. So again, it's just like with our ANOVAs, that we just kind of want to get all our ducks in a row, so when we get to computation time, we can just plug values into formulas and get it done speedily and accurately. So a scattergram sometimes is part of prep. Draw the graph first, get a sense of what the math answer should look like. But we're going to want all of these values. So we're going to want to know what the summation of raw scores for variable x is, the summation of the squared raw scores for variable x. The same 2 things for variable y. Remember, we've got 2 variables now. For our first time, back to 2 variables. We've got x's and y's. And then we want the summation of the products of x and y. So that's all stuff that we would do in a preparation stage for doing our two-tailed Pearson R. So now we can go on to actual step 1. Step 1 is still a hypothesis test, so it's still to state our hypotheses. And is eternally true? We've got 2 hypotheses, our alternate or research hypothesis and our null hypothesis. And as is generally always true for us, the alternate predicts that we will see something, there will be something there, and the null says, nah, nothing's happening. So the alternate says, yes, there will be a pattern, there will be a relationship, these variables will be connected. And the null says, nah, there is no connection here. It's what we call independence, right, from the slides, independence. So the alternate hypothesis is predicting covariance, that these 2 things will change together in a patterned way. For example, as one value goes up, the other value will go up with it. If we think about our classic example of height and shoe size that I used last way back in chapter 2, we find that as people's height measurements increase as they get taller, their shoe size measurements increase. They get bigger feet. They vary together. When one changes, the other one changes with it. Or if it was a negative relationship, right, when one goes up, the other goes down. They move opposite each other like a seesaw. So that's still changing together. When one goes up, the other goes the opposite direction. They are changing as a team. So either they're going together as a team up and down, or they're going opposite as a team, like a seesaw. So either way, the null says that there will be no pattern, no covariance, there will be independence. And this one says, no, they're going to change together. Now, we are not talking about treated population means because there is no treatment for correlation studies. We're simply describing variables as they naturally exist, seeing if there's any kind of pattern between them. So what we're looking for here is a measure of the relationship, Pearson R. So for the first time ever, we're going to use a different symbol here. It's called rho. I believe that's spelled R-H-O. That's a Greek lowercase r, so we're still using Greek letters in this, but it's almost impossible for me to draw it. You'll see it in the book. It looks almost like a lowercase p that's been italicized. As good as it gets. You know my handwriting, guys. So that's rho. Now, what we saw in the PowerPoint slides was that our correlation values are going to range from a value somewhere between +1 and -1. And that is, we get a 0 in the middle is saying there is zero relationship. So a math answer of a 0 here is telling us there is no relationship. But the alternate hypothesis says there will be a relationship. So our value for rho will not equal 0. We'll have more than no relationship. So the null says rho will equal 0. For a two-tailed test, that's how we write it. There's no other version of this. So what this means is that this test is not predicting, because it's two tails. Maybe they go up and down together, a positive relationship. Maybe they go up and down opposite, a negative direction, a negative relationship. Maybe it'll be higher than 0. Maybe it'll be lower than 0, but it won't be a 0. And again, the null will say, nah, that's going to be a 0. You're not going anywhere else. So that is our step 1 for two-tailed tests. We will pick up with step 2 in the next clip.